Eighth grade lesson 7.1 is equations with the variable on both sides. So we'll see equations that come up looking something like this, where you have a variable on this side of the equation and a variable on this side of the equation. And maybe some of your brains are like, oh, okay, I can do that. And maybe some of your brains are like, what? So this lesson will show you that you do have already all the tools in place, that you know what to do in this scenario. We're just going to put those pieces together so you can handle them. And they start off by showing us how to do this with algebra tiles. And that's really useful for your brain to see what's happening. So I'm going to take you through the first part where they explain that. With algebra tiles, then I will show you the calculation, which will become very familiar. It's all the pieces you've used in 6th and 7th grade, all the tools that you've been building, and then we'll apply it to a word problem. So let's start off looking at the algebra tiles. They put this on page 199, and their pretty artwork is way better than what I'm going to draw, but I'm going to go ahead and just draw it on here so that I can line things up nice and neat, so that it makes sense for my brain, because maybe that will make sense for your brain too. If you like it much more nice and neat in terms of what the book offers, you can look at what they have in there too. All right, let me go ahead and put my tiles. We'll start with the key they gave to us so that we can kind of recognize what each of these algebra tiles represent. So we have these little ones representing a positive 1. These red ones represent a negative 1, or opposite of positive 1. The long bars in algebra tiles represent the x. And here we have a 0 pair, where if you take a positive 1 and you put it together with a negative 1, you're going to end up with 0, and those are 0 pairs. And you probably by now recognize that as using an inverse operation. I'm going to do the opposite of plus to get back to 0. Well, opposite of plus 1 is minus 1 to get back to 0. So you've used the term or heard the term inverse operations or opposite operation to get me back to 0 again. 0 pairs is that. Okay, so let's go ahead and line up. I have this equation. Think of it like equations are always like a balanced scale. So I'm going to draw a scale here for our brains to kind of put together. Like those scales, that they're equal when they balance together. If you take one thing off one side, then you have to take it off the same amount off the other side, or else you go out of balance, right? So this is always what we're doing with equations. It's always this balance scale. So let's go ahead and model each of these, x plus 5 and 3x minus 1. Okay, so I've modeled this. This is 1x plus 5 ones. 1, 2, 3, 4, 5. Over here is 3 x's, 1, 2, 3, and a negative 1 right there. Okay, remember, I have a scale here that I want to keep balanced. But I want to get rid of some of this stuff on each side. I want x's on one side, and I want ones on the other side, the numbers on the other side. So I'm looking at this and I see, I can take this x off of there and I can keep it balanced by taking one of these x's off there. So if I take one x off this side, I've got to take one x off that side. So I'm going to do that. Off you go, off you go. And now that leaves me with that. So I have now 5 x's, 5 ones. Then over here I have 2 x's and a negative 1. Well, there's more of these over here than there are over here. I'm going to use 0 pair, the opposite or inverse operation of negative 1, to get it to 0. And in order to get a negative 1 to be 0, I have to add 1 to it. So I would add 1 positive to that side as well as to this side, because I have to keep, oopsie, that's the wrong color. I have to keep my equation balanced. So I added it to both sides. I'm messing that all up. So that I could get the 0 pair. These now cancel each other out, so they're gone. Now I just have 2 x's equals 6 ones. Well, if I have to share, if these two are going to share these equally, we're going to split them up. This one gets this many, and this one gets the other 3. They get equal amounts. That means that 1x gets 3 ones. There it is modeled. Now let's look at it mathematically. X plus 5 equals 3x minus 1. I'm looking at this equation. I like to kind of draw my ocean down here, my separation there. I want all of my x's on one side and all of my numbers on the other. And the biggest thing I see kids get nervous about is like, which one do I do first? Honestly, you get some choices. I can send all of these 5s, do inverse operation to get numbers over here. Or I can send inverse operation of this over there, or inverse operation of this over here, or inverse operation of that over here. I have lots of choices. I think I'm going to follow the plan they did here. If I'm going to go ahead and do inverse operation of a positive 1x, and I have to do that to both sides. Well, the inverse or the opposite of positive 1x is negative 1x. And if I did that to one side of the equation, I must do that to the other side of the equation. That cancels out a 0. This leaves me with 5 on this side of the equation. 3x minus 1x is 2x. Minus 1 still there. That's what I ended up with over here. Well, here before I got rid of that, I guess. So now my x's are over here and there's none over here. Great, that's what I want. I want them all on one side. But now I've got this constant here, this number over here, I want to be rid of. He is negative 1. I do the opposite of negative 1 or the inverse of negative 1, and that is positive 1. But I have to do that to the same side of the equation. That cancels out, leaves me with just 2x. 5 plus 1 is 6. And I think you're starting to find this is very familiar. Once you get to this point, that is stuff you worked on last year at 7th grade. This is just adding a new twist to it where we've got to move the x's or the variables around too, but we can do that. And then we're back to 7th grade when we learned multi-step equations. And now we've got ourselves down to what we learned in 6th grade with a one-step equation. 2 is being multiplied by x. The inverse or opposite of multiply by 2 is to divide by 2 to both sides of the equation. X equals 3. And that's what we got when we modeled it. Those are the mathematical steps that we will take. Okay, well, what in the world types of real life scenarios give us those sorts of equations? Well, let's have a look. We're going to read this. We're going to do all our steps. Read the question, underline the question, circle the information, draw a picture, and then we will solve it. So it says Andy's rental car charges an initial fee of $20 plus an additional $30 per day to rent a car. Probably in your brains you're starting to remember I've seen questions similar to this before. All right, we'll keep going. Buddy's rental car charges an initial fee of $36 plus an additional $28 per day. For what number of days is the total cost charged by the companies the same? Let's underline the question. For what number of days is the total cost charged by the companies the same or equal? Okay, circle the information. We have Andy's has an initial fee of $20 and then does $30 per day. Then we have Buddy's has an initial fee of $36 and then he charges $28 per day. Let's draw a picture. Rental car for Andy's rental cars. We know we're going to have to pay the $20 initial fee, but then we're also going to have to pay $30 for every day or multiplied by every day that we rent that. We know by now that we can say 30 times the amount of days we're going to rent that plus the $20 initial fee would be how my equation looks. Those have been practiced for the last several chapters, so I think by now you guys are feeling pretty comfortable there. Over here we've got Buddy's. Buddy. And he charges an initial fee of $36. That's more. But looks like $28 times however many days you're going to use it. So that's a little bit cheaper. So we have 28 times the amount of days. We'll call that 28x plus the initial fee. And again, their question was, at what point are they the same? When are they equal? So I came up with my equation for Andy's, my equation for Buddy, and I want to know when they're equal. There's our whole equation that we're going to solve. using the skills we just looked at. We don't need to use the modeling the tiles unless those really, really work for you, although laying out 28x and 30x's probably doesn't sound real appealing. Use what you know about inverse operations. And again, we have choices. I can send my 20 inverse operation to both sides so that all my numbers are on one side. I can send these 28x's inverse operation and do the same to this side. Like, I have all kinds of choices. It's not going to be wrong as long as you make sure you're balancing both sides. So I think what I'm going to do is I'm going to take these positive 28x's and do the inverse or the opposite of that. Negative 28x's. And as long as I do the same thing to the other side of the equation, I'll be fine. Those cancel out. I am left with 36 on this side of the equation. I have 30x's minus 28x's gives me 2x's. I still have that plus 20 hanging out there. So here is my new equation. Okay, this is starting to look like something I'm familiar with. I have 2x plus 20 equals 36. I'm going to get, since I have no variables over here and I have variables over here, I'm going to get this constant, this number, away. Opposite of positive 20 is negative 20. I must do the same thing to both sides of the equation. That cancels out, leaves me with 2x. 36 minus 20 is going to be 16. And now I have 2x equals 16. Well, x is being multiplied by 2. Inverse operation of multiply by 2 is to divide by 2. I will do that to both sides of the equation. X equals 16 divided by 2, which is 8. And remember, we were trying to find out what's the number of days that they will rent the car where it's equal. Well, that would be 8 days. So if you are renting a car for 8 days, it doesn't really matter if you use Buddies or Andes, it's going to cost the same. Now, because it's cheaper per day for Buddy than Andy, if you're renting for more than 8 days, go to Buddy. If you're renting for less than 8 days, go to Andy, right? It's good to know where they equal and don't matter which one you use, because it's also helpful to know, okay, if I'm doing more than that, then who's better? Well, more than 8 days, Buddy's better. Less than 8 days, Andy's better, because of his initial fee being less. So that's how you do these. We'll look at one more example. All right, a water tank holds 256 gallons, but it's leaking at a rate of 3 gallons per week. A second water tank holds 384 gallons, but it's leaking at a rate of 5 gallons per week. I think people need to buy better water tanks. Anyways, after how many weeks will the amount of water in the two tanks be the same? How many weeks until they are the same? We have one water tank that is holding, so that means it has, in positive, 256 gallons, but it is leaking and losing 3 gallons per week. 3 gallons for 1 week, and then again for 2, and then again for 3, repeated, right? A second water tank holds more water, 384 gallons, but it's leaking 5 gallons per week. Somebody fix these things, my goodness. Okay, let's draw our tanks. Water tank. This one holds 256 gallons, but it is leaking 3 gallons, not $3, 3 gallons each week. So so over and over again, it's 3 gallons coming out each week. So times however many weeks, we'll call it X. And that's a loss, right? So let's make sure we note that. It's a loss, negative. It's going out. So we have 256 gallons, and we're losing 3 gallons each week. That's the equation you would get there. Over here, we have a bigger tank. It's holding 384 gallons, but losing 5 each week. So we have positive 384 in there, but losing 5 gallons for each week. There's our set of equations translated from English into Math-Ese. When are they going to be the same? Let's do the calculations. Choices, I can move this there, I could go 4 different ways, really. I'm going to move, and here's my reasoning. I see this negative 3x, and I see this negative 5x. Inverse of them is positive. There's more positives that will go into this than over here, so it will end me with a positive number. Doesn't matter if you end up with negative numbers, you'll still get the right answer. Doesn't matter which choice we make, we'll still get the right answer. But you'll start to see tricks like, I like to try and keep things positive. I like to, and you'll start using them. So I'm going to go with the inverse operation of negative 5x, which is positive 5x. I must do that to both sides of my equation and combine my like terms. This is going to give me 256. I have negative 3x's and then I have 5. It's like owing $3 but having $5 in my pocket. I'm still going to have 2 x's. Okay. Now my variable is on one side of the equation. Now I'm down to what I learned in 7th grade. Let's get this number, inverse operation of that, to both sides. So this is a positive 256. I'm going to do negative 256 to cancel it out. But I must do that to the other side of the equation. I'll subtract those, and I'm going to get 8, 2, and 1. So I now have 2x equals 128. Inverse operation, x is being multiplied by 2, so I will divide by 2 to both sides of my equation. X equals 128 divided by 2 will give me 64 gallons. So they will be the same at the point that they're both holding 64 gallons, just for that 1 week. And then it will change after that. But at that one moment, 64 gallons is where they are the same. So the next section is not just asking us to solve this problem, which now you're probably feeling like, oh, I think I might be able to do that. It also wants you to be the storyteller, basically translating from math-ese into some English story. So, but this is really helpful for your brain to really be able to translate back and forth, because then when you're faced to translate English to math-ese, you're even better at it. So we need to think of a situation where I always think of money when I think of these things, where I have to pay $150 up front, but then I have a $25 per something amount, as opposed to where I just go $55 per however much. So, I mean, we could think of lots of scenarios. You probably have a few scenarios going through your brain. Let's say the gym. There's a gym near you that offers Zumba classes. I don't know, something like that. Although now I'm looking at that, it's quite a bit of money. A very expensive Zumba class. Gold-laced Zumba class, I guess. Anyways, the gym, if you're a member and you pay the $150 per month fee, it's a very expensive gym, $150 per month fee, then every Zumba class you go to will cost you $25 for that whole month on top of your $150 fee. Yikes. If you're not a member of the gym, you can still go to their Zumba classes. They'll charge you $55 for every class you go to that month. The question being, how many Zumba classes would you have to go to for these to be equal? Because if I know when they're equal, how many Zumba classes, I can decide, is this a better deal? Do I go to a whole bunch and I need this to be cheaper per Zumba class? Or do I not go to that many and it's cheaper not to pay that $150 fee, right? So there's my translation. You can come up with a translation of your own. You probably will come up with a way better one than mine. After you have come up with your story that goes along with it, we solve. I'm going to send my x's from this side, inverse operation, to this side. Cross off 150 equals 30x. Divide by 30. Divide by 30. You can see it becomes something very automatic. You know what you're doing. It's just the steps for the puzzle. And you're going to get 5 Zumba classes. So if I'm going to more than 5 Zumba classes each month, then I'm going to do this one because it's cheaper per Zumba class after the 5 days. 5 days, it doesn't matter. If I'm only going to 5, whichever. But if I go to 6, I don't want to spend 55 again after their equal point. I want to spend 25 instead. If I only go to 3, then I guess I'll do this. If I'm only going to 3 Zumba classes, I'm not even going to that gym. I'll find cheaper Zumba classes, for crying out loud, right? Anyways, that's all they're doing is create a story. It's good for your brain to kind of figure out so that when you have to translate out of their stories, you're understanding better. I think you're ready. I think you've got this, but you know where to find me if you don't and if you need help. But I believe in you.